Hi viewers, you are welcome to today's tutorial. Our topic today is friction. We'll be looking at friction between two bodies when they are in contact with one another. Now, on the board you can see force and motion. When these two combine together, what it will give us is what we call friction. Friction, that is, force and motion is going to give us friction. What is friction? A friction is a force which opposes the relative motion of two bodies in contact with one another. Now, from this definition we see that friction involves two bodies, and for this frictional force to occur, the two bodies must be in contact with one another. When one moves, friction will take place. It shows that a body cannot move without force. That is why one of the agents that causes motion is force. When there is force, a body will move. So in this class, we'll be looking at frictional force in three different aspects. Number one, when a body is on horizontal floor. The friction of a body on horizontal floor. Number two, the friction of a body over an inclined plane. That is the second one we'll be looking at under this topic. Then the third one, we'll be looking at the motion of a body motion of two bodies when they are connected over inextensible string. Then we want to look at how friction can take place in between the two. So we start with friction. The first one, friction of a body on horizontal plane. Friction of a body on horizontal plane. Now let's look at it. This is horizontal plane. This is horizontal plane. The surface of this plane can be smooth. It can also be a rough surface. But we'll be looking at it. If it is rough, we use this one to indicate that this surface is rough. If it is smooth, all this will not be there. Whether it is rough or smooth, we are looking at the motion of a body when we are having it on this plane. Now, let's say if I have a body A on this plane and a force F is applied to this body, which tends to move it in this direction. Now that you have seen the force that is applied, this force that you are seeing here is called applied force. This is what we call applied force. Applied force. This is the application of force that anybody can apply to move this body on this platform. Then, according to the definition of friction, that when the two bodies are in contact, this is first body, which is representing the surface. Then this is the second one, which is another body, and you can see they are in contact with one another. Now, when this body applies to this, there is something that's going to happen. We are going to have frictional force. According to the definition, frictional force opposes relative motion. Frictional force. This is frictional force. Now, from the law of gravity, when a body is on the horizontal floor like this, there are two forces that are acting on that body. Number one, the weight of this body A, which is mg, mass multiplied by acceleration due to gravity. And the reaction from the floor, not reaction from the body, because the body is standing on this floor, that means it's strengthening this body. That means the body will react. So the reaction is going to be normal. We call it normal reaction. Why is it called normal reaction? It is called normal reaction because the body is perpendicular to the plane. So it is called normal reaction. Now let's see. There are two things that we need to consider in this diagram. Number one, we are looking at it when it's at equilibrium. Equilibrium means when the body is not moving. That is, normal reaction is equal to weight of the body. Then the second one, the applied force is equal to frictional force. That is the first thing that we need to take note. It's very important. At equilibrium, that is when the body is at rest, the two forces that is acting according to gravity, that means they are equal. Then, since they are equal, the applied force is equal to what? To the frictional force. Now, we want to look at this very important aspect here. That is when the body is in motion. When the body A is in motion. When the body is in motion, what will now happen? Let's go back to our diagram. According to definition of force, now for this applied force to move this body, it shows that this applied force F has to overcome this frictional force, which means that according to the definition of force, force is a product of mass and its acceleration. It shows that it wants to set the body moving. Now, once this force F is applied to this body here in order to set it in motion, it shows that part of this body F, part of the force F, will be used to overcome the frictional force. Then the remaining part of the force F is the one that will set the body in motion. Let me take this for example. When you have, for example, let's look at when a tug of war, we can have like 4 people here. We have like 4 people here. We can have like 2 people here, 2 people, and these 2 guys here against these 4 guys. They are trying to drag this rope. You know that this is 2 against 4. You will see that because of lot of force is here, they will overcome this one. 2 of this one will cancel out these 2. Nothing is here, that is 0. But here we are still having 2 force, that is 2 newtons here. Each of them, assuming that they are having 1 newton, each of them. It shows that these 2 is the one that will pull these guys that are here. That is what I'm talking about. That is part of these forces that these 4 guys put in there will be used to overcome these 2. The remaining will now set this body to move. The same thing applicable here. So now look at it. When the body is in motion, we now have the applied force. Since it is greater than the frictional force, will now be minus the frictional force, which is equal to resultant force. Resultant force can also be called net force. It can also be called net force. Then net force can be defined as the product of mass and the acceleration. The mass that we are seeing here is the mass of the body A. Then the acceleration A is the acceleration of the body when it starts moving on a straight line. So therefore, let's go back to this and put this AMA in place of resultant force. This implies that force, the applied force, minus frictional force is equal to MA. Now, with this equation now, I will call it equation 1. With this equation, we can calculate the force, the applied force. We can calculate the frictional force. We can calculate the mass of the body. or acceleration depending on that question. Now let's take it this way. Now if you look at it, maybe we have for example, this is the mass of the body, and the mass of the body is 20 kilogram, and a force of 50 newtons is applied to the body, and a frictional force of, let's say, 10 newtons. And the question now says that we should calculate the acceleration of the body. You can see now we should calculate the acceleration of the body. Now to find the acceleration, we just go back to the diagram. Look at the applied force here. Look at the frictional force. From the definition, you go to this formula, then you now see it. Where is the applied force? Applied force is equal to 50 newtons. Frictional force is equal to 10 newtons. Mass of the body is equal to 20 kilogram. And we are calculating the acceleration. The acceleration is unknown. One of the methods of solving physics calculation that will make it more simpler is you need to write all your parameters, knowing both the unknown ones and the known ones. So you now know the perfect equation that you are going to apply. So let's go back to equation 1. We now have applied force minus frictional force is equal to mass times acceleration. That will be 50 minus 40, 10 minus 10 equals to mass is 20 multiplied by the acceleration. So here we now have this one will give us 40 equals to 20a. So by the time we now divide both sides by 20, we have 40 over 20. So our acceleration is equal to 2 meters per second square. Now these are simple questions that can come up from this number 1. Now in our next class, we'll be looking at another part of this force. You can say that, let me give you what we are going to do next class, so that you will not miss out and you know how you will come for this class next time. Prepare your mind. We have this. What we have done today is, you can see that the force is applied horizontal, which is horizontal parallel to the plane. We want to look at the situation that, what if this force is now applied making an angle with the plane? What will now happen? The applied force is now making an angle with the horizontal. This one that we did, the applied force is parallel with the horizontal. Now what if the force is making an angle theta, a particular angle theta? How can we now calculate the applied force or the frictional force? This is what we'll be doing next time, still on this part of friction that we are doing. Then in the next class, we also look at the property of friction, how we can determine the coefficient of static friction. Make sure you subscribe to this channel and share with your friends. Thanks for watching. See you in the next video.